we have already done it last year, so I will not be proving to you how they are derived. This session is just to help you recollect what you have learned last year. Okay, there are total of 4 angle properties, okay, that we must remember. Okay, what are the 4 properties? Can anybody just shout one?
Angle at center.
Angle at center equal twice angle at arc, shall we? Anyone? Okay, angle at center equal twice angle at arc. Angles in the same segment, very good. Angle in a semicircle, last one. Butterfly.
Is it the one where they meet and no one is
The one that they made, no, not quite. Angles? Opposite angles of a cyclic chord, or angles in opposite segment. Okay, I'll run through all these 4 with you now. Okay, the first one, Crysta mentioned, angle at center equal twice angle at arc. The key word over here in this property is the word?
center.
Everybody, the key word is the word? Center. Okay, the key word is the word center. When you have an angle, okay, that's subtended between 2 radii, in this case OA and OB, the angle that is formed, okay, subtended by these 2 angles, will always be twice, 2 times bigger, okay, than the angle that's at the arc. Okay, so if this angle here is, let's say, 120 degrees, then the angle that's at the arc will be 60 degrees. Okay, it will be half the size. The angle at the circumference, the angle at the arc, will be half the size of the angle that's subtended at the center of the circle. Are we cool with this? How did I help you to remember this last year? Was like, remember, I talked about this. If this was to be an eyeball, you know, you put on your mascara, the eyeball is looking at this particular arc. Am I right? The eyeball is looking at this minor arc AB. Can you find another angle that can form this eyeball that is also looking at the same arc AB? You realize angle ACB. If this eyeball is also looking at the angle, is also looking at the arc AB. Okay, when these 2 angles are looking, these 2 eyeballs, they're looking at the same arc, then the angle at the center must be 2 times the angle at the arc. Are we cool with this? I don't want you girls just to remember this shape. A lot of students, I share with you, they just memorize this shape, the arrow shape. This itself is not enough. There can be another variation to this. If I were to draw it this way, look. You have a circle, center O, I draw it this way. This looks like our butterfly one. Remember our butterfly angle, right? Okay, but is this our butterfly property?
No.
No. Why not? Because
all
4 vertices does not touch they are not on the circumference of a circle. And what we have is center O. Right? You look, this is your arrow shape, this is your arrow shape, this is your arrow shape. But this doesn't look like arrow at all. In fact, it looks like a butterfly. But the property of angle at center equals to twice angle applies as well. Okay, let me draw it for you to let you visualize this. Look at this angle. The angle that is formed in the center, right, by these 2 radii, OP and OQ. The angle at the arc, see, if I will trace this 2 line out, see, the angle is facing this arc PQ. Can you find an angle that is also facing this arc PQ? You trace back. PRQ. So this angle, if this is the eyeball, is looking at, this is an eyeball. Both the eyeball are looking at PQ. Right? See, so if this is 70 degrees, then this must be 35. Are we clear with this? Okay? So we don't just memorize arrowhead, no. This also applies. Okay, so this property is called angle at center equals to twice angle at circumference. Or you can say twice angle at arc, ARC. Are we cool with this? What is the key word we must, the moment we see this word or we hear this word, very likely we know we're going to use it probably. What is the key word for the first property? The word? The word? Center, right? The word center. Everybody say center. Center, right? Okay, the second property, Arabella, can you remember? Angle in a semicircle. Very good. What is the key word? Rachel, what is the key word for what Arabella has mentioned? Angle in a semicircle, right? Angle in a semicircle. What is the key word? D word is a D word. Very good. Diameter. Okay? No, not diabetes. Diameter. Okay, diameter. If this is the diameter A or B, okay? The property of an angle in a semicircle basically states that if I were to project two chords, okay, and they were to meet one another at the circumference of a circle, then, okay, let's say they meet at point C, okay, C lies on the circumference of a circle, then angle ACD must be right angle. It must be 90 degrees. Are we clear? It must be 90 degrees. So this is what the property angle in a semicircle states. Okay, when you have a diameter, from the two ends of a diameter, if you are able to project them, if they will meet one another at the circumference of a circle, then that angle from die must be 90 degrees. Must be 90 degrees. Okay? And last year, I remember I went through a question at you. If I have an angle that's inside the circle, will it be bigger than 90 or smaller than 90? It will be smaller or bigger? Come on, think about it. Okay? If the line AC and the line BC were to meet one another, if they meet inside the circle, will the angle ACB be bigger than 90 or smaller than 90?
It depends on the size of the circle.
Depends on the size of the circle?
I think it's smaller.
Smaller? Okay, think about it.
I think it's bigger.
Bigger or smaller? Let's draw. Let's just sketch. Think about it. Just draw. And if they meet one another, look just by looking at it. Bigger or smaller? Bigger. Let's do the opposite. What if they were to meet one another outside the circle? Come on, look at it. This is bigger or smaller? Obviously smaller, right? This is small. This is definitely a cube. It's an angle that's smaller than 90 degrees. If the two lines AC and BC meet each other outside the circle, then the angle formed must be a cube, smaller than 90. Okay? But if it is on the circumference of a circle, it must be 90 degrees. Why? Angle in a semicircle. So if it is inside the circle, outside the circle is smaller, inside the circle it must be bigger. Okay, the next property, the third property of in the angle properties, right? Can somebody remember? Look at this shape on the board. A, B, C, D. Gives you the what? The butterfly shape, right? So the butterfly shape tells you, reminds you of which property? Angles in the same segment. Very good. Angles in the same segment, right? Over here, the key thing you must take note of, okay? The key thing you must take note of is you must have how many points? 4 points. And all 4 points must be on the circumference of a circle. Okay? We do a very quick recap. The first one, angle at center equal to a second arc. The key word is center. The second one, angle in the semicircle. The key word is diameter. The third one, butterfly. 我是蝴蝶. So this one, what is the key? The key thing you must take note of. You must have how many points? 4 points. All 4 points must be on the circumference of the circle. Okay. Shuja, tell me what does angles in the same segment state? What does it state? If angle ABD is 55 degrees, then
ACD will be 55.
ACD is also 55 degrees. Okay, this is what the angles in the same segment states. Okay, what is this all about? In English, it looks like this. If I have two angles, okay, again, we're talking about 4 points here. Okay, Felicia, we're talking about 4 points here. All 4 points must be on the circumference of the circle. Butterfly shape, the hourglass, the ribbon. Okay? Look, look. Eyeball, mascara. If this angle here is looking, look, it's looking at this minor arc AD. Can you find another angle that shares the same arc? ACD. Right? The point line again, red eyeball, mascara. So over here, this angle in red here, ACD, is also facing the same arc. When the two angles, they share the same arc, they must be of the same size. If this is 55, this must also be 55 degrees. Am I clear?
I have a question.
Yes.
Does that mean that Does it mean that one also is 55 because it's also looking at the same point?
This one?
No, that one, the one in the middle.
Is this angle also 55 degrees? What do you all think?
No, it's not 55.
Okay, hold on. I have one response that says it is it is twice 55. It is 110. Okay? What do you think? Do you think it is 110?
Do you know there's no center?
Oh, very good, very good. It brings us back to this point. Is there a center O? My dear, if this is center O, yes. Rashika is definitely correct. Then AOD is 110. It will be double, right? It is double. Right? But over here, did I say that this point is the center O? Did I say that this intersection is center O? No. So tell me, can this angle here be 110? Will it be double? No, it cannot be double. Cannot be. Okay? So let's answer Crysta's question. Is this angle 55 degrees? Since it is also an angle that is looking at the same arc. What do you all think? Nicole, what do you think? No. Why not?
Because it's not touching the...
Very good. Because this angle here is not touching the circle. It's not on the circumference of the circle. See this angle? It's on the circumference of the circle. You see this point, see? The angle is formed, right? It's on the circumference of the circle. Is this point here, let's say I call this point E. Is point E on the circumference of the circle? No. So, this is not true. It will not be 55 degrees. Okay? Can everybody clear? Can I move on to the last one? Okay, the last you must know would be it will be what? We have already done angle at center, because angle R, angle at semicircle, angle in the same segment. The last one is what Felicia mentioned. It's opposite angles of a cyclic chord. Another way of naming this property, opposite angles of cyclic chord, would be angles in opposite segment. Okay, what does this property, what is the key thing you must look out for in this particular property?
4 points touching.
4 points on the circle. Then that is very similar to our angles in the same segment. 4 points. But do you have a butterfly shape?
No.
Do you have a ribbon shape? Hourglass?
No.
No. So what shape must you have? You must have a quadrilateral. Very good. Quadrilateral means a 4-sided closed figure, right? So made of straight lines, all connected. So over here we have a quadrilateral that's sitting on the circle. All 4 points must be on the circumference of a circle. That's why we call this a cyclic quadrilateral. Okay, what does this property say? If angle SPQ is 110 degrees, then
Angle SRQ.
very good. Angle SRQ will be how much? Is it 110 also? 70 degrees. Very good. Okay. If angle SPQ is 110 degrees, then angle SRQ will be 70 degrees. They're not the same, but they are, what is the S word that I shared with you? They are?
Supplementary.
Very good. They are supplementary. Okay, what does supplementary mean? It means they add up to 180 degrees. If two angles add up to 90 degrees, what are they called? Complementary. Very good. They're called complementary if they add up to 90 degrees. Are we clear?
Get it now!